Okay, yet again, we're going to write a base protonation constant expression, which sounds very scary, but really we're just going to do Kb. And they're giving us dimethylamine C5H13N, which is a weak base. I never want to write this out, but because they are requiring us in this problem to do so, I'm going to take this ugliness and I'm going to throw it into water. Because isn't that what we do always? C5H13N. This is aqueous. We're going to throw it into water. Now, what do bases do that is different than acids? Well, bases, they grab hydrogens. So this guy right here is going to grab hydrogens. It's going to grab hydrogens off of this. Now, you know you've done this correctly because if a hydrogen leaves the H2O, won't we end up with OH minus? And that's a telltale sign that we're dealing with a Kb expression. But then over here, this C5H13N, it's going to grab a hydrogen onto it. So when that happens, what we're going to end up with is this whole thing, C5H13N, but it's not going to be 13 anymore. I'm going to add an H onto this. And when I do that, I end up with a plus because the H is a plus and we had a neutral thing to begin with. So how do I write all this into my expression? Well, I'm going to write my products. I don't know why I put a B right there. Let's make that into a B from a P. I'm going to write C5H13NH plus all of that concentration times OH minus. I got kind of lazy with the symbols up here, but these are aqueous and we have water, which is always a liquid. And over on the side, we're going to write C5H13N. This is our overall expression. This right here is what we're going to put into this right here. Hopefully this has been helpful.